For decades, we've looked to space telescopes, Hubble, James Webb, Chandra, and others, to reveal the universe with a clarity that Earth could never offer. But now, something unexpected has happened. A telescope still anchored to the ground, still breathing Earth's atmosphere, has delivered images so vast, so detailed, and so shockingly deep that astronomers around the world stopped what they were doing. Because for the first time, the Vera Rubin Observatory has opened its eyes. And what it saw on its first night isn't just beautiful, it's unsettling. It's a glimpse into a sky so crowded, so dynamic, and so alive with activity that it threatens to rewrite how we map the universe. A camera the size of a small car captures 3.2 billion pixels at once. A single exposure is wide enough to hold 40 moons. The resulting dataset will grow so massive that it could take lifetimes to interpret. And yet, the very first images already contain secrets. Merging galaxies, newborn stars, tens of thousands of ancient clusters, and more asteroids in 10 hours than the rest of humanity found in weeks. This is the moment astronomers have waited for. A machine powerful enough to watch the sky change, catch cosmic events in the instant they happen, and reveal structures we didn't even know existed. Tonight, we're diving into what the Vera Rubin telescope has just seen, and why its first images have shaken the scientific world. Long before the first images were released, the Rubin Observatory was already a legend waiting to be born. Perched atop Cerro Pachón in Chile, one of the driest, clearest, and darkest places on Earth, it was designed not just to take pictures, but to survey the universe in a way no other observatory ever has. At its heart is the Simone Survey Telescope, a three-mirror design unlike typical two-mirror systems, giving it a sharpness and field of view unmatched by telescopes of its size. The primary mirror alone spans 8.4 meters. But what truly sets Rubin apart is the fusion of its optics with the largest digital camera ever built. This camera weighs nearly 3 tons, stretches 3 meters long, and captures ultraviolet, visible, and near-infrared light with stunning precision. But where Rubin begins to defy expectations is in its scale. One image covers 10 square degrees, an area equivalent to 45 full moons. In a single snapshot, Rubin sees what would take Hubble thousands of images to assemble. And as it completes its scans every 3 days, it doesn't just produce static portraits. It builds a time-lapse movie of the universe, exposing the flickers, pulses, collisions, and transformations happening all around us. This is not a telescope built to look at one object. It is built to look at everything all at once. When Rubin captured its first images in June 2025, astronomers expected something impressive, but they were not prepared for what the observatory actually delivered. After just over 10 hours of test observations, Rubin produced a mosaic that the scientific community quickly nicknamed the Cosmic Treasure Chest, a breathtaking 25-square-degree portrait of the southern Virgo cluster, the closest large galaxy cluster to the Milky Way. This image, stitched together from 1,185 exposures, contains millions of stars and galaxies. Spiral galaxies stretch their arms lazily across space. Merging galaxies twist together like cosmic smoke. Filaments connect distant clusters in web-like structures. In the background, barely visible unless you zoom in, lies a sea of faint reddish galaxies, each one a possible host to billions of planets. And this overwhelming richness represents just 0.05% of what Rubin will detect. The observatory is set to reveal 20 billion galaxies, and this first mosaic is just a preview. The trailer for a decade-long film The Universe is about to broadcast through Rubin's lenses. As astronomers explored the mosaic, they found not just beauty, but unfiltered cosmic evolution, structures forming, interacting, fading, and expanding, captured in detail so immense that it reshapes our understanding of what a first image can be. If the first mosaic demonstrated Rubin's power, its next release proved something even more astonishing, that a ground-based telescope could rival space observatories in depth and scale. The Rubin team unveiled a wide-field mosaic of the Lagoon Nebula, a star-forming region about 5,200 light-years away. Normally, when we see the Lagoon Nebula, it's through narrow, zoomed-in images from telescopes like Hubble. But Rubin showed us something else entirely, a panorama where the nebula, despite spanning 55 light-years, occupies only a fraction of the frame. Surrounding it are countless points of light, open clusters like Messier 21, the glowing Trifid Nebula, Bach 14, and the densely packed globular cluster in GC 6544. In a single image, Rubin captured structures that exist at wildly different distances and scales, from newborn stars in the nebula's core to ancient globular clusters thousands of light-years farther away. This is the consequence of Rubin's staggering field of view. Hubble sees about 1% of the moon's surface in a single image. Rubin sees 40 moons at once. And yet, even with this immense view, its details remain sharp, intricate, and layered. For the first time, we see the lagoon not as an isolated object, but as a connected piece of a much larger cosmic landscape, a neighborhood filled with birth, death, chaos, and motion. Rubin wasn't built just to create pretty pictures. It was designed to revolutionize astronomy. And even in these early tests, it's already doing exactly that. In just 10 hours, the observatory identified 2,141 new asteroids, including 7 near-Earth asteroids. To put that into perspective, the world's combined observatories typically detect around 20,000 asteroids a year. Rubin is poised to discover millions in its first few years alone. It may become the single greatest tool humanity has for detecting and tracking potential impact threats long before they come near our planet.